So, matter, anything that occupies space and has mass. Hopefully we already have that definition down, because now we're going to talk about mass specifically. Measurement that reflects the amount of matter. And here we're talking about the particles of matter in the object. Okay? How many atoms, molecules, particles are in there. That's the matter. Because matter is different than weight. Weight takes into account the pull of the gravity of, like, say, Earth. So here, your mass and your weight may seem very similar, but if you go on the moon, the mass is still the same mass as it would be on Earth, but on the moon, the weight is a lot lighter because the pull of gravity is a lot less. So, measurement of the amount of matter, we're really talking about, like, the particles that make you up. Okay? So let's take a look here. Chemistry, the study of composition, structure, and transformation of matter. So that's what we're looking at here. Some of this is kind of review of what we've done in the past, but we're going to build up. Substances, remember, are elements or compounds. They are made up of the same particles. And they don't have a change in composition. They're uniform. Physical properties can be observed in these pure substances. Characteristic that can be observed without changing the sample's composition. Now we're going to talk about the two types of physical properties. There are ones called intensive and one called extensive. Intensive properties are ones that are not dependent on the amount. Okay, the amount of matter does not matter. It is not going to change the property. Whereas extensive properties do depend on the amount. Okay? So, for example, I have 100 milliliters of water and I have, 2 liters of water. 2 liters is a lot more than the 100 milliliters of water. I put them both on a hot plate and I heat them up to start making them vaporize into a gas. What temperature are they going to boil at? What temperature does water boil? 100 degrees Celsius. So does it matter if it's 100 milliliters or 2 liters? They're both going to boil at 100 degrees. So that is what we would call an intensive property, because it doesn't matter how much you have, still going to retain that same number. Density is another one that's big on intensive. The amount of particles packed in the amount of space, that doesn't really change with the amount that you have. Some ones that do change, like mass. You have more of it, you're going to have a more mass. You have a longer amount versus shorter amount. Those ones are going to be there. One that a lot of people don't think of that is extensive is heat. Heat is actually an extensive property. Why is heat an extensive property? Well, let's think about this. If I'm burning a log, or if I'm burning a twig, which one's going to produce more heat? The log, because the log has more matter. So it's going to be able to give off more heat. So therefore, heat is an extensive property. It does depend on the amount. Okay? So let's talk. Keep going. Some of the other important reliable properties listed here, like density. We already know this one, the mass per unit volume. Boiling point. Boiling point has to do with the temperature at which a liquid changes into a gas. We definitely need to review that. That's important for the test next week. Melting point. Temperature at which a solid changes to a liquid. Okay? Yes, you got to remember these phase changes. That's important for the test. Melting point is just the temperature at which it occurs. Melting is the actual process from going from the solid to the liquid. Remember, you're breaking those forces, spreading out the particles. So it's not as compact as the solid. It's now more fluid like the liquid. The particles have more movement, more kinetic energy. Now Now, a couple of these others listed here, like ductility, I introduce it now. It's a metal property. Okay, property of the metal to form wires, like copper wire. We need that copper wire because it is the basis of pretty much our whole electrical system. Malleability is the ability to pound metals into sheets, and we use lots of sheeted metal, okay, or formed into sheets. That's another way to say it, like aluminum foil, but like sheets of steel. These things are important in our building. We use them all the time. Okay, so very important properties. These ones are pretty reliable. There's a couple other, like luster for metals. Luster's like shiny. Metals are shiny. But some that are not always reliable could be color, because what you think is yellow, I might think is more orange. So sometimes color is not the most reliable type of physical property, but we do use it. Texture, odor, those kind of things. But do you think that, you know, some of these properties are affected by amounts? That would be your extensive properties, and the ones that are not affected by the amounts being your intensive properties. Okay? So let's talk a little bit more. Chemical properties. Substances to combine and change into one or more substances. So when we have a chemical reaction, you have bonds breaking and bonds forming, new substances being produced. There are a series of indicators that let us know a chemical reaction has taken place, and you saw most of them on the first day of school. You saw the bubbling, which was the gas being produced. You felt that it was heating up in the demonstration. I touched the bottom, it was really warm. Okay. You saw the color, you saw some color changes going on, brown gas and so forth. Now, physical changes, basically you should be able to put it back the way it was. And we'll be demonstrating where we can physically separate mixtures in our lab tomorrow and on Thursday by doing separation techniques. Chemical reactions, though, should not be reversible. Like burning a log into ash, you're not going to be able to recreate the wood. The chemical makeup is definitely changed. So you would have to engage in another reaction in order for it to change. Some of the examples up here, raw egg becomes cooked egg. The baking of a cake where you have the batter being changed into a solid. Paper becoming ash, or even the steel being having rusting, that rusty powder stuff off of it, it's eating away at the metal. That is a chemical reaction. Corrosion, decomposition, stuff like that's always going to be chemical because it's breaking stuff down into new components. Signs of chemical change right here. Color change, heat absorbed. Heat's absorbed, it gets cooler. Just like it did on the first day of school, we did the Alka-Seltzer and the vinegar, the temperature went down, it got cooler. That means it was absorbing heat from the surroundings. So that would be endothermic. We say that's endothermic when heat is absorbed. Exothermic, the one also on the first day when you had the petty and the acid and it got really warm, it was giving off heat, releasing heat. That would be exothermic. So anything where you have to absorb heat or give off heat, you're going to see the heat changes. That's an indicator of chemical change. Bubbles or gas release, and precipitate form, as you see here under the hood. You see my blue precipitate. You see the liquid on top. The precipitate has settled down there. That is because I've combined different things that have formed a solid, and you see the color change falling to the bottom with the blue there. Those precipitates are those recrystallizing of a solid. Two solutions that are completely, don't have any solid in it. You put them together and you get a solid at the bottom. You know a precipitate has formed. Okay? So going over endo and exo one more time, just so you know the difference. Heat is released, it feels warm or hot to you, you know it's going to be exothermic, like heat is leaving or exiting. Heat is being absorbed, it feels cold, because the heat is being absorbed. So when I put my hand on the board, my hand feels cold. That's because the heat is transferring from my hand and going into the board. The board is absorbing my heat. So it feels cold to me.